Now see, we are working on the basics of springs right now at this point of time. We're clearly working on the basics of the spring. Now see, when you have a spring, you have a spring like this. Let the spring is of spring constant K and is of natural length some L. Remember, at this stage, the spring won't exert any force. Now, this spring, if it has undergone a stretching of L0 plus X, there will be some tension in the string. And that tension is given as a Kx, where K is a force constant of the spring. Similarly, if it is compressed, you have stretched here. Here you have applied a force F like this. In this case, the spring will experience a force of Kx, L0 minus X. Right. In both the occasions, you can see that there is an elongation, there is a compression. There is an elongation and a compression. In all these cases, work done by spring in both the cases is minus a half K X square. Already I taught you this in the last week. Last week, when I have defined work. Also, please note that a spring is cut into two parts. It has a cut into two parts. Now here it is force constant K and its natural length is L0. Now the moment you cut, you have divided that as two parts. One is of length K1, one is of length L1, the other is of length L2. Then what will happen in this case is, in this case, K1 becomes KL0 by, what is that? No, L1, which is nothing but K times L1 plus L2 by L1. Similarly, K2 is nothing but KL0 by L2, K times L1 plus L2 by L2. Got the point? Any doubts? Are we clear? Pakka? Right. Now the question is, if the springs are connected in series, you have two springs like this. We have already done all these basics in springs chapter, Newton laws. This is equivalent to K series such that 1 by K series is 1 by K1 plus 1 by K2. Remember, in this case, tension in each spring is the same. F. Here in this case, tension is different. Tension in springs are different. Elongations are same. So entire week I will run with these fundamentals only. Entire week. Okay? Right. Now we will start with the very fundamental model. Block of mass M. Before that, let me just see. I require one more fundamental model. Before this, I require one more fundamental model. I'll discuss that and I'll come to here later on. See, this is the natural length of the spring. And you released this block from rest. Now, what will happen in this? There are different stages that you need to understand. There is one such stage where the block will deform the spring. Remember, in this case, the block will move down by y. Remember, in this case, different forces exerted. I'll just display here. The spring will exert a force of ky upwards, weight mg downwards, instantaneous velocity v downwards. Now here, once again, that is the equilibrium level compression. What is the meaning of equilibrium? Now you can see that it has a downward acceleration actually. In this stage, it has a downward acceleration. At this stage, this will have maximum velocity. You know why maximum velocity? Acceleration is 0. You know why acceleration is 0? At this stage, ky equilibrium and mg, ky equilibrium and mg remains the same. So till this point, weight dominates. At that point, weight force and spring force balances. At that point, velocity attains maximum. And thereafter, what happens? It will go down with the deceleration. It keeps moving down with the deceleration. It may have a downward velocity, but upward acceleration. And thereafter, sometime later, Y max. Loss in potential. No, see, please try to understand here. The block will experience maximum upward acceleration. And the instantaneous velocity is 0. So this is called maximum compression state. This is relaxed stage. And this is equilibrium stage. Remember, in all these occasions, block is dropped just with 0 initial velocity. Now, please try to understand. I will define this as a stage A, and I will define this as a stage B, and I will define this as stage C. And we will take this line as our standard reference, no issues. The law of conservation of energy, you can apply across any of these stages because none of the forces are dissipative here. What are the forces here? One is spring force, other is weight force. Both are conservative. So when all the internal forces are conservative, you can comfortably apply law of conservation of energy. If even friction is there, you cannot apply law of conservation of energy. In that case, you should apply law work energy theorem. Actually, here when I am speaking about law of conservation of energy, in this context, I am speaking about law of conservation of mechanical energy. I am speaking strictly about law of conservation of mechanical energy. Now, therefore, total energy at A is same as total energy at B is same as total energy at C. You got the point? Now, what is the total energy? See, with reference to here, it is only potential energy. mgy max. Total energy at B. You lost 1 minute. No, see, here it is. What are the different forms of energies here? One is half Ky equilibrium square plus there is no 1 minute. You lost y max minus y equilibrium because that is where your height is. Plus half m v maximum square, which is equal to what is the total energy at C? Gravitational potential energy 0, kinetic energy 0. Any energy if you have, that is only maximum square. Please tell me, have you understood this particular equation? So there is only one term here. 0 plus 0. No Ke, no elastic potential energy. You have all the three forms of energy here. Here you have only one form of energy. Ke 0, potential energy 0, a gravitational potential energy 0, elastic potential energy exists. Now what you can do is you equate extreme conditions first. This is half K y maximum square. So therefore, y maximum is 2mg by K. And one more important point, you said this exists. So therefore, this is nothing but 2 times y equilibrium. If you want maximum velocity at the equilibrium point, again, you use any of these two equations. mg y max is half K y equilibrium square plus mg y max minus y equilibrium plus half m v maximum square. mg y max Y equilibrium square. What is Y equilibrium square? mg square by k square. Y max is 2y equilibrium. You said that. Y equilibrium. So mg by k plus half m V maximum square. So you please carefully try to do all these things. So what is going to happen? 2 times mg square by k minus mg square by k minus mg square by k. Are 2k here. So this is half m V maximum square. So from this you can write V maximum is root last time V max is equal to 2 cancel. I'm just concluding this simply. M by K. Root M by K times G. Agreed? Boys and girls. Agreed? That's all. So this is the fundamental approach of a vertical springer. Even you can repeat the same for all the things are same, even for suspension type situation also. You can have same, everything is the same in case of this type of arrangement also. Whether this case or this case, rule is the same. Only thing is, in the first case, you will have what? Compression. In this case, you will have elongation. Remember, all this is true when the block is dropped from rest. Right. So I am proceeding further because you will have the notes with you. Yeah. With this, why don't you try 8.51 by your own? Why don't you try 8.51 by your own? Right. What is the difference between the previous case and the present case? In the previous case, at this point, block is at rest. You dropped it from rest. There is no K at all. Now the entire story is different. Now, the moment when you are here, it is a velocity root 2gh. Remember, we will take this as our standard reference. Right. For our convenience, we will call this as U hereafter. And this is a relaxed length. Relaxed length. Relax a minute. Got a point? Now what happens? See, please try to understand. One thing is still common. What is common? Can you please explain me? Equilibrium position is still common because mg kx, that combination you cannot do any big difference. At this point, this is some point where assume that the spring has maximum equilibrium. Still, my point is very clear. At this point, ky equilibrium is still same as mg. But who cares for this? In this question, I don't want this. I want maximum compression only. So what is the last stage? The last stage situation is Y max, maximum compression. I am just again going to do the same condition. So let me take this as A, let me take this as B. Don't use Y max is 2Y equilibrium here. That is true only when the block is released from rest. Y max is, yeah, half. Why don't we compare the situations of A with B? Total law of conservation of energy at A and B. So mgy max plus, array, this time it has kinetic energy also, no spring energy. Potential energy stored in the spring is 0 at A. What's all the forms of energy that you observed across A, across B, you will have a situation where what do you call, the potential energy is 0, kinetic energy is 0, and any energy, it is stored is spring energy of max. Now I can see a quadratic equation here. If you can observe, I can see a quadratic equation here. What is that quadratic equation? Zero. So quadratic equation, Y max is plus mg plus or minus b square minus 4ac mg square plus, or because there is a minus term here, 4 akalla denominator lo 2 2s unnai, km u square by 2a. Okay. Or minus is not possible, you know. So therefore, Y max is simply mg plus mg square plus. By the way, can you please help me in writing u square? U square is 2gh. K m 2gh by k. So this can be written as mg by k plus mg by k whole square plus 2mgh by k. By log, this is Y max. Right. That's all. So that is one of the basic observation. One among the basic observation. Now, please post your comment on this. Any doubts on this? Are you sure? Right. Let us proceed further. Fifth question and sixth question. Both are same concepts. A ring of mass m is equal to 10 kg can slide through a vertical rod with friction. It is connected with a spring of force constant. You have K is equal to how much? 400 Newton per meter. The relaxed length of the spring is 4. Ring is displaced by 3, as shown in the figure, and released. Find velocity of ring when the spring becomes horizontal. Remember, at this point, say it has some velocity v. And don't forget, it is in vertical plane. This is as per my understanding, because it's a vertical rod. Remember the moment, what is the relaxed length of the spring? 4. Now it is 5 meters. Now at this stage, it is elongated. We will call this as state A, and we will call this as state B. Apply, tell me, apply law of conservation of energy across AB. At A, at B. At A, what is the total energy? mg into 3 plus. Friction akkada smooth ega without friction ayi untundi. With friction aithe avvadu cheyaledu adi. Slide through a vertical rod without friction ayi untundi. With friction aithe cheyadam kashtam avutundi. Normal reaction point to point maripotundi. Right. mg into 3 plus, but good observation. I appreciate that. And what is the elongation at this stage? Area 4 and 5. Natural length is 4, elongated length is 5. So elongation is 1 meter. Half K E square. When it comes to here, it's totally half mv square. Right. So I am 10 into 3 plus half into 400 into elongation 1 square is half into mass 10 into velocity square. $300 plus 200 is 5v square. Clearly, v square is 100 and v is 10 meter per second. So how should I correct is without friction? That is without friction. With friction, you cannot do. Okay, you can do, but it's a complicated question. Point to point, normal reaction will change. Right. Now go for the sixth question. In figure, the stiffness of the spring is K and mass M of the block is M. The pulley is fixed. Initially, the block M is held such that the elongation, initially spring is relaxed. If the block comes down by Y, it is the same elongation in the spring. See, two things are there. One thing is very clear. Now this is the block. The block will have 2 stages. Stage 1, stage 2, stage 3. Yet one spring is relaxed. Spring is relaxed. At 2, On the block mg ke1 elongation, and ke1 is equal to mg. In that case, velocity is maximum, of course, maximum. At stage 3, ke2 mg, velocity 0, maximum acceleration upwards. That's all. Now, how I will handle this situation? Simple. According to me, this case and the very first case which I have discussed is the same. How? I'll explain. So, mg E1 is the loss in potential energy. This is nothing but gain in kinetic energy plus gain in elastic potential energy. Remove E1 here, first of all. This will become mg square by k is half mv maximum square plus half k E1 mg square by k square, which implies half mv maximum square is half k mg square by k. So what is V maximum? V maximum is under root mg square by mk. That is the maximum velocity. What do you want? Maximum elongation. Rare maximum elongation is also a simple calculation, which is nothing but half, mge2 is a loss in gravitational potential energy. Entire thing is stored as elastic potential energy. So therefore, the maximum elongation is nothing but 2mg by k. Just to substitute, you'll get the values. Do you have any doubt in this? Pakka? Sure? Everyone in the class? Right. Now, you please work on this question right now. Quickly work on this question. I expect everyone to solve this question. It's a very good question, actually. And the figure shows a block of mass m attached to the spring, and another block of mass 2m has been placed over it. The system is in equilibrium. The block are pushed down so that the spring compresses further by 9 mg by k. System is released. At what height above the position of the release The block of mass 2m will lose contact with the other block. At what height above the position of the release? See, what is that you need to observe in this question? I'll explain. So practically, we'll take this line as a reference line. Practically, this is the relaxed length of the spring. When both the blocks are there, for a while, you can take that total system as 3m, no issues. So therefore, this is nothing but 3mg by k. That is 3mg by k. Till this point, any doubt? And in this, you further compressed by 9mg by k. Right, which means right. But this is the worst situation of a compression. Now what happened? It will keep going up. At what height above the position of release, the block of mass 2m will lose contact with the other block. Why such a situation arrives? See, the loss of contact will not happen in this zone. Why I will explain. You take any block. Now see, remember it will have an acceleration A up, pseudo force MA plus weight and normal reaction. Now tell me, in this zone, is it possible for normal reaction to be zero on any of the block? Okay, below red line. Okay, or at least above the equilibrium point that you can take. For example, you take this line like this, at least below red line, below the equilibrium position. Above the equilibrium position, what happens is and this may have a downward acceleration. There might have some pseudo force MA like this and weight mg like this. Normal reaction N0 is possible when A is equal to G. And this happens above red line. Below red line, it is, we have nothing to discuss situation related to below red line. We will discuss anything above red line. So now they are asking any height above this reference blue line. At what height above the position of release, the block of mass 2m will lose contact with the other block. So you require an acceleration equivalent to g. Right, no issues. G in which direction? Downwards. Right. Suppose I am taking some position here and some position here where the acceleration is directed down by G. Right. At this point on the system, what exactly is the force? 3mg and ky. One minute. E1. E1 is calculated from where? From here. Or from here. This is the reference line. E1. Somewhere at this point, I'm asking about E1. So you want a situation where 3mg minus ke1 is equal to 3m A. 3ma. My goodness. You want a condition where A is equal to G. It is possible when E1 is equal to 0. You know, it is possible when it just reaches that point. E1 0 means spring is relaxed. Spring is relaxed means what height I can take from here? 9mg by k plus 3mg by k, which is going to be 12mg by k. First part is done. What is the maximum height attained by 2m above the point of release? Now, first thing that you give me clarity that it loses contact immediately when it reaches 12 mg by k height from the given situation. This is an Irido question also. There is a question in Irido like this. I am proceeding further. I am proceeding further. So, for in the process of proceeding further, right? When I'm proceeding further, which means I don't want all this stuff. I don't want all this stuff because I already used this. I don't want all this stuff. I just want to see the moment when the combined arrangement reaches here. 3m reaches here. I want to see what is going to be the velocity. That's what I want. Because at this point, 2m lose contact with m. But till that moment, that instant, they will have a common velocity. Simple. I'll apply law of conservation of energy. At these two positions, I'll call this as B, I'll call this as C. Apply law of conservation of energy between B and C. So from here to here, there is a, no, what are the energies here? Half K 12 mg by K whole square. That's all here. The total energy at this point is elastic potential energy. Gravitation 0, kinetic 0. But the moment when you reach here, 3mg times 12 mg by K, gravitational potential energy, plus half 3m v square plus 0. Why 0? Spring is relaxed. At that instant, the moment when you reach there, spring is relaxed. Are we clear? Pakka? Sure? Now, what is happening over here? In this case, V square. Hold on. Now we need to solve this. 12 square minus 12 square by 2 minus 36 times ma ఒరే 36 MD హోల్ స్క్వేర్ అది సాల్వ్ చేసావా ఓకే నువ్వు బలివాడు నేనేమో తప్పు ఈజ్ ఈక్వల్ టు హాఫ్ 3m V స్క్వేర్ ఆ V స్క్వేర్ ఏమొచ్చింది నీకు 12 స్క్వేర్ కదా దీన్ని ఎలా రాసుకోవచ్చు ఇది 12 3s ఇది 12 12s మొత్తం 72 72 minus 36 36 36 ఈ 3 to 12 24 so actually V square is అంతేగా 24 వస్తున్నాగు వస్తుంది ఏదో చెప్తున్నా చెప్పండి ఒకసారి 24 times mg whole square by m into k కరెక్టేగా అది ఎప్పుడురా మిమ్మల్ని అడిగింది అసలు నేను అడిగాను అది అడగల నేను అడిగింది ఏంటో తెలుసా ఇక్కడి నుంచి ఇప్పుడు ఇది ఏమవుతుంది వర్టికల్లీ ప్రొజెక్టెడ్ బాడీ అయిపోతుంది కదా సో అంటే యూ రిక్వైర్ హెచ్ మ్యాక్స్ విచ్ ఈజ్ నథింగ్ బట్ వి స్క్వేర్ బై 2g substitute in that you should get so h max is equal to v square by 2g which is nothing but 12 times mg square by mk ఊరి ఆన్సర్ తప్పు వచ్చిందని అనకండి వాడు అడిగిన క్వశ్చన్ మీరు మర్చిపోకండి అబౌవ్ ద పాయింట్ ఆఫ్ రిలీజ్ సో అబౌవ్ ద పాయింట్ ఆఫ్ రిలీజ్ తీసుకుంటే దిస్ ఈజ్ ఆల్రెడీ 12 mg by k ఇది ఇంకా మళ్ళీ ఏమొచ్చింది నీకు వి స్క్వేర్ బై 2g చేస్తే ఇంటూ 2g కూడా చేయాలి చేస్తే ఏమొస్తుంది మీకు ఇది కూడా మళ్ళా 12 mg by k వస్తుంది సో టోటల్ వచ్చేసి ఏమవుతుంది ఫ్రమ్ పాయింట్ ఆఫ్ రిలీజ్ it is going to be 24 mg by k. Okay, are we clear? So actually, I have just introduced the questions. Now tomorrow, you see, this week onwards, I'll slightly change my approach. All easy, I will leave it to you. All moderate and difficult, I will discuss in class. Right. Now you see, all these questions are very, very, asalu at the end of this week, say by Wednesday, you will be in a state that spring is nothing for you. You will reach perfection in handling spring models. I want to see you in that stage. Remember, these are all 20 pages totally, all are on springs only. Right. Power and vertical circular motion comes in next week, actually. Okay? Right.